Hello again. This time I have brought another great tutorial for you. This tutorial is related with full stack programming or especially with front-end engineering. And in this tutorial, we are going to build the United States wildfire map using Chakra UI and various other React components. The reason I have chosen Chakra UI because it's very interesting. First, you can build web UI even faster because you are not going to deal with CSS and other styling separately while you are creating your content and building your layout. At the same time, you can make sure that you are also able to control the styling of the components. So it helps you to build the project faster. Second, we are using the United States wildfire data, which we have downloaded directly from the United States Department of Agriculture and other website. And this tutorial is end to end. It means you are going to start everything from scratch, downloading the data, building your Chakra UI layout, and finally writing your code step by step and building various map layouts such as heat map, scatter map, hex map. So overall, you are going to enjoy working on this project. Once again, my name is Avkash and I will get you started now. I will give you the review of the project we are going to create in this tutorial. So this tutorial or this completed application, what you are seeing right now, is completed after we have completed our exercise. So when you start this application, you see that there is a US wildfire visualization. All those results are available for us and we can look the US wildfire data for the Hawaii as well as for the all 50 states of United States, and we are not selecting the Alaska data in this project. But you can very easily combine your data as if you would want to create that as well. Here, as you could see, that this is a scattered plot which shows that wildfire data, which is similar to if we look into the active fire image as of now. So that's the active fire. Here is the Hawaii and here is the active fire map look like, and this is the active fire map which we have created. And here you could see that these patch shows your intensity of the fire in various places within the United States. So we have scatter plot. We also have the hex map. What hex map is that if we go a little more deeper, here you are going to see the hexagons. So these are all the pink hexagons, and what these sticks you are seeing, these sticks shows that for a given hexagon, how many times the wildfire happen in that area. So this data we are using in this project has only 7-day length, and that's what we are seeing from here, that the data points which we are using for our graph has 54,000 data points. We can see the 3 days worth of resolution, or we can see the 7 days worth of resolution. We can also see the resolution based on particular instrument. We can select only MODIS instrument, or we can select, we need to select VIIRS, okay, and the data what you are going to see is related with VIIRS. If you select MODIS, and that data you are going to see is related with MODIS. So depending on which one you are interested, you select and you okay, and then that data you are going to see. The fire confidence, which is between 0 to 100, 1 to 100, and in 3 different category, low, medium, high, that can also be checked here. And as you could see that we have ability to change the resolution for this hex map. And you can see that some of these values, how they are being updated. If we close this, we look into the scattered plot for all data. That's what we have. And if you want to change the file fire confidence slider, you are going to see that how your date visualization changes. So what fire confidence is that when you are moving from 0 to 100 range and you are just looking into the upper ranges, which is in 70 to 100 maybe, it means that these are the area where the fire confidence is very high. It means the instruments are detecting these heat and they convert this whole heat into a fire signature based on certain algorithms, and it seems that okay, these are the places where the fire or chances for a wildfire are there. The maps design as are also accessible, so you could choose a dark map, which is currently the dark map. You can also choose the gray map, or you can choose the street map. So depending on your choice, you have ability to do some customization within your map. 3 days data, 7 days data. So it just tells that 3 days means recent 3 days. So in recent 3 days where the fire was being seen more prominently. So this will be our target for today's project. We are going to build the scatter plot, hex map, as well as we are also going to filter our data in a variety of ways so we could build our application or front-end application to consume the United States wildfire data, which is something similar to like that, but I really didn't go very deep to build exactly because the time was limited. So I decided that in the given time, we can at least build some functional component, and I should be able to give you the gist of everything, how you could build a really versatile application if you would want to create it. We are looking at the fire information for resource management system US and Canada website. At this website, you can always look at the live wildfire details globally. You can choose United States and Canada map, or if you would want to look at the global, you can select the global map as well. This website is combination of the efforts from NASA as well as the US Department of Agriculture and other ministries also involved. What you are seeing in this website is the data which is available based on today's satellite information, last 24 hours, as well as the last 7 days. So there is a history behind how this whole data is being collected, but in nutshell, there are 3 different satellites are used, and 3 of these satellites are having 2 different instruments. So on these 3 satellites, these 2 instruments are onboarded. One is MODIS and the second one is the VIIRS. If you are interested in learning more about these instruments and how everything really works, I would suggest you to look at these links, MODIS and VIIRS, and here you are going to learn a lot about how this data is collected, the architecture, all that information behind it. I'm not going to go a lot over there. What our objective in today's project is that we need to understand the data set which is used in order to build this fire or wildfire information website on today 24-hour and 7-day resolution. So we could learn, and we can also build a similar system for ourselves. That's one objective we have. Second, we also need to understand how the geo-spatial data can be used to build a front-end application. So if somebody who is very new to deal with a geo data where you have longitude and latitude and other information associated with longitude and latitude, so how to build the front end or UI using that data. That's kind of our objective, and the wildfire data is really very good to play with or good to experiment with. So let's take a look at the data set now. So if you would want to get the data, you can look the historical data at this archive download website where you can get all that data available. These 2 different instruments, MODIS and VIIRS, and you can get almost 20-year worth of data as well as the data from 2012. So these instruments, they read the satellite data differently. The resolutions are different, like a 10, some up to certain meters all the way to certain kilometers. So that's what they really try to go and collect these resolution images, and then they used more mathematics top of it to predict the confidence of a particular signal to be wildfire or not. So that's where you are going to get the archival or very old data. However, the latest data or the active fire data on up to 7-day resolution, that is all available here. So for this project, we are going to work with the data which is available here, and we are going to use the data for the US and Hawaii 7 days data. So for this project, you need to download this file. You also need to download this file, and you also need to download this file. So these 3 different files which has CSV data into it will be the target or the source for our project to render the wildfire information which is visible here. So now we have downloaded the data set. We are going to take a look. This is what data set really look like. So you have longitude and latitude. So looks like these are the same files. They open 2 times. So here we have longitude, latitude, brightness, scan, track, acquire date. So acquire date is important for us, latitude and longitude, and the confidence. So here you can see that confidence are nominal. So there are 3 different values you are going to find. You are find low, nominal, and high. If we look into the modest data, you are going to see the one big difference is that the modest data does have the confidence value range from 0 or 1 all the way to 100. So the VIIRS data shows the confidence value in 3 different labels or 3 different categories, versus the modest data is available from 1 to 100 range. Rest of these informations are more related with the data, but they will not be a lot more practical for us to use. So our focus will be to use the longitude, latitude data based on acquired date, as well as the satellite, or mostly the type of the instruments, whether it's a modest data or it's a VIIRS data, and what is the confidence of that particular file. So these 2 data set we are going to use for our project. So next step for us will be to now try to work on our data so we can prepare our data so we could use it for our front-end web application. In summary, at this point, you can spend some time to learn more about the data and the data set and the various collection methods available for you to scan through. Second step, you need to download these active fire data for the 7 days resolution, because we are going to build up our front-end application which shows the last 7 days worth of United States and Hawaii wildfire data. In this step, our objective is to take this CSV data which we have recently downloaded and convert it into the JSON format data. Because mostly when any application we build, full stack application, we usually have the backend and frontend, and backend send the data to the frontend through the API calls, and when this data is being sent, it's mostly sent in a JSON format. So the frontend has easier way to process the JSON objects. So in this example, we will take this data, convert it into the JSON files, and we will use those JSON file as our source for the front-end application. To convert CSV to JSON, I will be CSV to JSON converter. I will look into just any publicly available, and here is our JSON to CSV converter. So I will just open first modest data. So here is our modest data. I will open with one of the text editor, copy. So that's the modest data I have used here. I will select parse numbers. So all the correct numbers could be parsed properly. And we are trying to set the output as an array format. So convert, and here is our conversion happen. So the data what you are seeing here as a longitude, latitude, brightness, all those fields are created as a JSON format. And all these records, which are about 5,000 to 8,000 records, they are all converted into the JSON. So we will take this data and download it. So we got CSV to JSON, first one, and we just call it modis JSON. Next, if you would want, we can actually select the second file here. So I will be selecting this time the J1 VIIRS, J1 VIIRS. That file is loaded, and as you could see here that it has the confidence is a categorical. It means that this is a VIIRS. Let's convert it to, and conversion happen. So let's download this file too. So we have downloaded this, and now select the third one. This time we are going to select the Suomi VIIRS. Let's open. So that is also being uploaded. Now parse numbers, array, and convert, and conversion completed. So that will be our third file for Suomi VIIRS. So that data is also downloaded. So the first one was the J1. So I will name it VIIRS J1 Wildfire, and second I will call it VIIRS Suomi, Suomi, and that is also Wildfire, and this one was modis Wildfire JSON. So we have got these three JSON file. So this is a modis Wildfire, and if I want to create the VIIRS JSON data, so I just call it VIIRS Wildfire JSON, and I will take the data which is out from Suomi all the way from here to last, and I will take this VIIRS, open it, and merge it at the very bottom. Save. We no longer need this. So now we have 15 meg VIIRS Wildfire data and about 2.3 meg modis Wildfire JSON data. So these two JSON file will be our source data set for this project. For our front-end application to show the United States wildfire visualization, we are going to use the Chakra UI as our base. So Chakra UI is based on React, and you can use Chakra UI to build applications with really fast speed. And reason is that because majority of the components are already available for you. One. Second, the way this Chakra UI is designed is that you really do not need to depend on too much CSS. Majority of the components can be built in a way that their style sheet are already included into the component properties, or the component parameters. So if you would want to change the component design, layout, or component look and feel, everything you could write directly into the component. You don't really need to build the style sheet and then you need to bring the style sheet into the component. So everything all at once. So that's the reason we have chosen the Chakra UI. And to connect the map or the map layer, or how we are going to show this wildfire data to the UI, we are using the React Mapbox GL. And Mapbox GL is a React component which works with Chakra UI, and combining these two, we are going to render the maps in our front-end application. So this application, what you are seeing here, is actually the combination of Chakra UI plus the React Map GL. And underneath, we are using the Mapbox library or Mapbox support, which really helps us to render these maps and let us play with geographic data or geospatial data. To use the React Mapbox GL or to show the maps, you have to have the Mapbox account, and using this Mapbox account, you will be able to create your own key, and this key will be used by the application which is going to render the map data. So for that reason, you need to make sure that you do have an account with Mapbox, and you also have the Mapbox access key or Mapbox access token. So this token will be used with our application, and I will be showing you when I will be writing the code. So first you need Chakra knowledge a little about it. Then you need to have an idea that we are going to use the React Mapbox GL, and in order to use this, you have to have the Mapbox account. We are also going to use the component like DACGL, and DACGL is another React related library to render maps, and there are several examples available. So if you are interested to learn more about the DACGL in your front-end application, feel free to select any of these applications, and you are going to get the full code as well as how to write that code in your React-based front-end application. So before we start, I just wanted to let you know that a couple of days back, I have already created a tutorial where I showed that how you can use React Map GL plus DACGL with Chakra UI. So in this tutorial, you are going to get a lot more deeper information about how to start working on a Chakra UI application from scratch, and then integrate React Map GL and DACGL, everything, and build various maps as shown in this example. As you could see here, because here I have shown two examples, but if you go inside in this application, you are going to get several other maps built into, and I will show you a couple of here. So if we go map, you can get the DACGL example, scattered plot. You can get these arc layer map, text scatter plot. So how to put the dots and text the way you would want. Various text layer. Here actually you are seeing this text information. So it's a text map, but if we go more deeper, and you can actually see this is the text is being written here. Or hex map. So this is the hex map on the New York area. So that's what you are seeing here. And finally the text and hex map together. So here you could see that combination of various network or various map layers. Here you can see we have text, we have point, we have hex and stacked hex. So these are the examples are available in this tutorial. So what we are going to do is that we are going to use the source code from this tutorial, means the output of this tutorial, as you could see here, in this tutorial we started from a starter code and we completed the final code. So the input for our tutorial will be the final code. It means this code already has the Mapbox related code, and I will also walk you through very quickly that how we have added the Mapbox code. But just for your information, we are going to use the something similar design structure to build our Wildfire visualization Chakra UI application. So please go ahead and spend some time and learn more about implementing React Map GL and the DACGL into the Chakra UI application. Now let's take this React Map GL DACGL demo, which is located at Chakra UI tutorial folder in public code repo, and use this map data demo final as our base project for this tutorial. So Chakra UI tutorial, and here is the React Map.gl demo. So I will be creating a new folder here. It's called the Wildfire Chakra UI demo, and use this final project. We do not need, let's create the folder this, and we just need the code this, and this. So that our final demo. And if we try to take a look between these two projects, very quickly you could see that this starter code is the base Chakra UI React template code. This, and when we complete this project using the React Map.gl component, we add those components here, and those components are added into in this area. So we have already added the routes in this project, and within those routes there are pages, and there is something called the map home. So map home is where the implementation is. So I will spend 5 minutes after I start the project here in Visual Studio Code, and I will walk you through whole code. So I will close this. We do not need. So that our demo final, and this will be the same for the starter. So a starter code and the final code is exactly the same as of now. So a starter code will be used by anyone who would want to follow this tutorial and complete at their own pace. The final code will be the one where we will start in our tutorial, and by end of the tutorial we will complete all of our work, and we will push this whole code to the GitHub repo, so it will be available for anybody to work on this project. So we have created, and I will name this project to Wildfire Demo Final, and that will be called the Wildfire Demo Starter. Now let's come back to command line. In the public code, Chakra UI tutorials, we have Wildfire Chakra UI demo, and here our Wildfire Demo Final and Wildfire Demo Starter. Status git add. Let me see if there is anything. Okay, only readme. So git add, git commit, and we can say that Wildfire Chakra UI demo base code is added. If you look into the Chakra UI tutorial, Wildfire Chakra UI demo, now these two folders are added. At this point, we will also open the final code in Visual Studio Code and review it. New window. So we have open public code Chakra UI Wildfire, and here is the Wildfire Final. So we will be using Wildfire Final. Code is all here. So let me install the packages required for this demo. So Wildfire Demo Final and npm install, because we have just created this whole base folder structure. So node modules folder is created, all the dependencies are added for ourselves. At this point we can go Chakra UI Wildfire Final, npm run start. Okay, server is started, and here is the map home. So if we go home, that's the base folder where everything is running. So it's a React Chakra UI template code, and it has two index home, two routes, index home, and also the map home. So actually there is a one map home where you can get these maps related code already working, and you can also get, I think, the data home. So here is the data home. So two routes are already created. So let's take a look into the code. So the app.js has the app router. App router is already created into the components, routes, index. And here in the app router, this index, data home, and map home is defined, and switch statement is added, which selects which component is selected. So if you select the data home, it will be rendered based on this whole switch statement. If none of these routes are defined, then by default it will go to index. It means if we come here and we just call anything, it will roll back to index here. That's what is happening here. So that's where now we look into the map home or the data home. So data home, the definition of the page is in data home. So that's where the pages, the data home is defined, and that's where it connect to the container. So this is the container. So from here, data home goes to container code where is definition. So tomorrow, if you would want to add the Redux and other components, and you would want to have the various other functionality to make a call to the backend server and fetch the data, everything you can implement in this data home EX, and then it jump to, or the control jump to your implementation of this full code, which is data home. And here is the full implementation. Similar to data home, we also have the implementation for full map home. So we come to map. Here is the map home where the placeholder is for map home. Control goes back to container where everything is. And if we look into the implementation part of map home, that's where you see that all the maps are being created, and depending on what your selection is, you can render the maps. And how this map control is built into, first you need to have the libraries. Here you need to have these libraries: Mapbox.gl, React Map.gl, DAC.gl, and then DAC.gl React aggregation layers and the geo layers. So these libraries help you to render the map data on your Chakra UI based front-end code along with the React Map.gl. So that's packages you really needed. After that, you need to make sure that wherever you want to render your application, you just really need to select whatever component you want. So for example, if right now is rendering the text hex scatter map, and here you are using the static map DAC.gl that is defined here. DAC.gl is calling a static map, and within this static map you are rendering your map style. So here is your map style, here is everything in between. So this return is basically what render the given layer, and you are going to define the layer. So whole system is just three pieces. First, you need to define the layer. Second, you need to set up the container, which is the DAC.gl and static map. And a static map, you set up whatever map design style you would want, and the layers will be injected into your system. And third component is from where you want to start. So that's where initial view state. So initial view state, you always define from where your viewpoint is going to start. So it's a three-layer system for you to create map. And I have explained this whole thing in detail in this tutorial. So once again, I would request you to please spend about an hour and learn in depth how to get this whole thing working together. So this was our sample app. If we go to map home, we come here and this rendering happen. So now in this code, we will take this map code, we will convert this whole thing to a menu, so we can see all those things as click based. So you have general understanding of how this whole code is really created. Routes are already added, so please review this code. And if you are very new to Chakra UI and you do not know how to even add the routes, I have a full playlist from Chakra basis all the way to adding routes, adding Redux states, adding layouts, everything is there. So please visit my YouTube channel and search for Chakra UI tutorials, and you will find all that information what is really needed for you to get ready to this point where you can add the Wildfire data visualization to your Chakra UI application. So my next step will be to create about 60 pixel header at the top and render the map underneath in this whole available height as well as the overall available width in this map. So we are going to create the box width equals 100% available. We will use a style min height 60 pixel, max height 60 pixels. So now our height is fixed, and we will give background, just call it red, or maybe call it blue. So our height is there, and we will put this text inside and just call it map. Remaining of this will 100 height will be calculate 100 vertical height minus 60 px. So what we have done is that for this box, which is this, so this is vertical stack, so two boxes are there, width is 100 vertical width, and we are calculating the height, calculate 100 vertical, okay, and this should be, so height is equal to, there you go. So either we use this complete or we could remove altogether. So that would be our, and that's, you see that, okay, so our header is created, but this map is basically superimposing. So we need to make this thing relative. So right now this text scatter map, so wherever it's being rendered, you can say curly braces. So we have set up this style, and now as you could see here that this thing is built into in proper stack mode. So we have set this thing up. Now in the map home we need to create a button group and build these buttons. I will remove this. Here is our button group. So this button group is created and it sets up a map choice. So by default our map choice is, for example, the scatter plot. So that's our default choice. And here are the buttons. So when click will happen, it will set up the particular choice. Let's look into, it's a button group and button is not defined. Button group. As you could see that these buttons are added. Now we need to add code, so we could show these maps on click event, and here is the code. So depending on map choice, it renders a particular component. So all these choices which we have listed here, they are all going to be rendered here. As now the only problem is that we need to set up the position relative for all those components. So we can go one by one. First come here and copy this line, go to React map, and here we need to, this is React map GL, set up position relative, tag GL, set position relative, scatter plot, set position relative, text clear map, position relative, text scatter plot map, R clear map, hex hex map, and finally text we have already done here. Let's take a look. Now, depending on which graph or map you are interested to look into, you are always going to get everything set as expected. So we have done this thing for our map home. Now exact thing we are going to do for Wildfire. So we need to create a new route called Wildfire home, and we implement something similar over there. So at this point, I will come this section. So let's add a new route. So you are going to learn how to add a new route. So I will define this route called Wildfire home, or Wildfire map will be a good idea. Wildfire map, and we call it Wildfire map home. So that needs to be defined here. So it's going to be Wildfire map home, and that will be a folder called Wildfire. So pages Wildfire. So I need to come to the pages. Here is my pages data map. I will be creating a new folder called Wildfire. Similar to implementation and container, I will be creating a folder called Wildfire here, and I will be also creating folder Wildfire here. So we have created all together at once. So after we have created these three folders, Wildfire, Wildfire, and Wildfire, and we have defined that Wildfire map home will be our first place. So we are going to create very first the pages Wildfire. Our file name will be wildfire map home.js, and here we are going to create the Wildfire. So similar to this, I will select this. I will call it Wildfire home ex, and that is what is going to render, and the return of this, the type of class, this is Wildfire map home. And Wildfire map home. So that's we have defined. And once you have a page, you need to connect with container, because that's where the implementation is going to be. This is a Wildfire, and it will be similar to this ex. So now we need to come to the container Wildfire, and we need to create map home ex.js. So that will be our file. We will look into this code, copy, paste here, and it will be Wildfire name, exact name, and we need to set up the implementation exactly here, and folder will be Wildfire. And remember, we are doing this because in case we need to fetch the data from backend, then this container implementation is going to help. Setting up Redux state, connecting with backend, everything is going to be happen here, but we are not doing any of such things in this tutorial. Now we come here to the implementations Wildfire. Here is our implementation, here is our Wildfire. So we are going to create .jsx, and similar to data home, we will have to implement our code here. So if we look into here, we can look into what is the map home look like. Something this will be our objective. So just for starter, I would say that our code will be something similar to this. So I will just use partial of this code, and we will have the type of map. I will just use none of this code, empty code, only one button to start with, no implementation. So this is our base, and it will be Wildfire map home ex. That's all is really going to be used by us, and I think we just need these and done. That's all. So now our wildfire map home EX is added. And if we look into the whole hierarchy, we have defined wildfire map is here, and that is implemented in this wildfire map home object, which is connected with wildfire map home in the pages. We came here, define wildfire map home. Now we go to container, connected. From container we go to implementation. Implementation is nothing but just a fancy hello world. Just save it. Let's see if our route is added correctly. So we call it wildfire map, and that's great. You see, so our implementation, what we have added, is added here. So let's make it. Now what we will do is that we will do implementation side by side. So that will be our code to write, and here will be our browser side by side. So we could implement our code and see the results as it is happening in real time. So this will be our map. If we would want to make this thing side by side, so this is our box. So it's a vertical stack. I will call it horizontal stack, this box, and I will convert this thing into the two boxes. Box 50%, box width 50%, and I will drop this button group here, and here I will have the text style. I will say Excel and wildfire map visualization. H-stack is not defined. As you could see, this thing, now we can make it left align and right align. We can say align, and so this will go right side, this will go front, and if we want to make it 2XL, so wildfire, if we want to make padding, so we can say padding X equals to 3X, and that will, it's a 2 padding. So that, and padding 1, margin top 1, there will be some margin. So if click happen, we could see the map here. So that's what we have set it up, and now we will be able to build our wildfire map. Now at this point, if you remember, we have added our JSON data. So this exercise we have done earlier. So our next step would be to take this JSON data and convert them to the JavaScript array object, so we could access this data. So we are going to come here in the utils or the data. In the data, we are going to create a folder called wildfire, and here we will take this data which belongs to modis wildfire and VIIRS wildfire. We will create these two objects and store here. So first I will create new file, modis wildfire, new file, modis wildfire data .js wildfire data equals, and this whole modis wildfire JSON data which we have here, open in here, take this whole code, copy and paste here. So that is the whole modis data is saved here. So Modis wildfire data is stored here, everything. That's for Modis. Now we say VIIRS wildfire data.js, and that is similar to Modis. We can also say, so some Modis wildfire data, we can say export const VIIRS wildfire data equals, this is it's about 15 meg file, so definitely we need to make sure we could read it correctly. File is loaded, whole data is copied here, and there you go. So I have pasted it. It's taking some time because data is really very large. About 70,000 lines are there. So that data is also loaded. So we have VIIRS wildfire data, MODIS wildfire data. So these two files I have added based on our data. Let me close this here, and then this one. So now this is the place where we have this data. So I will try to import those data files here so we could access them. So import Modis wildfire data from so it should be data wildfire, and it's a Modis. Same thing, import VIIRS wildfire data from data wildfire VIIRS. So both of these components are loaded, and if we would want to show the call and make sure that we could see the length, we can say dot length for the first one, and that value will be the text, and same thing we can do text. And if we save it, that's use here wildfire map. Finally, the length for these two data set is visible here. Let's try to set up px. So we have padding. Now you could see that the Modis wildfire data set, we have 7,320 rows, and for the VIIRS we have 49, almost 50,000 rows. So about 58,000 rows we have in our data set. So at least we know that our source data is available for us to work with. We are going to use this data set and try to build our very first wildfire map. So here is the wildfire implementation. I will be creating folder called widgets, and here I will be building the wildfire scatter map .jsx. So that will be our main code. So let's have these three things we needed. Okay, and that's where. So if we look into the scattered map template in this map, as you could see here, we do have a scattered map template here. So a scattered map template is something like this. So I will be using this template and I will explain everything here. So we are importing a static map and .gl. So .gl is our main container and static map inside here. So there we need to define the layers I'm coming into. So layer we are using the scatter plot layer. So this is our define functions. It will be wildfire scatter map, and the data is already coming into. So this will be our code. So we can define this as a props because we need props here. So let's define the props, and everything else here we can make them const. Radius 10. We do not need this. None of this map style is needed. So we const is our map style. There you go. That's it. Start from here, return here, and that's so our wildfire scatter map is designed. Initial view is a longitude, latitude, not needed. The scatter plot map is defined. ID is scatter plot. Data will be coming into the props, so it will be props dot whatever we are going to send from here. So let's make a call, import, and so we are calling it wildfire scatter map, and from here. So that's correct. That's our component, and we just called it wildfire data equals, we are sending this data. Let's use one of it, and that will be the wildfire data is used here. Props. Update triggers, we do not need any of this. Get fill color, not needed. And so if we try to load here, that's our map. So as you could see here, the map is added, and because our database is related with United States, so let's try to zoom it out. So our zoom will be, let's try to use zoom 4. If we reload, let's try to use zoom 3. Okay, and we need to move a little bit right, so that will be our center. So here we are negative, so we need to use the higher numbers, maybe use 104. Reload. I think that's good. So that's, and if we want this, we need a little more zoom, so zoom will be 2, and that's pretty much. So we could see our map when this loads up. Now we need to look into the data. We need to put the position, which is the coordinates. So in our scenario, the coordinates going to be the d dot latitude and d dot longitude. So let's convert this to d dot. So first will be longitude, second will be latitude. Okay. Radius, put 10, so it will be bigger. And as you could see here, some of this data is rendering here. Yes, okay. So we need to radius scale 200. Okay, so we are seeing these scattered plot is coming. So it's just a very simple scattered plot of wildfire map. We have seen it. But as you see that this is really not going to help us in any way, because our data is very different. The data is something like this. It means that we need to show the heat map, how various coordinates are showing the data and what is the confidence value. So our data is basically 4 fields are very important for us: longitude, latitude, the date when it was acquired, and the confidence value. So the confidence value is what going to show the heat map color. Higher confidence, higher color. And that's what we need to show. And scatter map is not the answer for us. So it means that at least while our test is good, our code is working, the scatter plot will not be a choice for us. And if we want to put color here we can actually define the color to 55, 100, 100. So that will use the red color. So you got a very good idea that how very quickly you could build the scatter plot, but that is what not our real objective is. So what we are going to do is that we are going to build the another widget and we call it Wildfire heat map. Similar to scatter map, the most of the code is going to be similar. So we can look into the heat map. So this is hex map and scatter plot map, GL heat map layer. So this layer is something which we could reuse for ourselves. So Wildfire heat map. So that will be Wildfire heat map. Data is not coming. Map style is there. Data will be coming by us. So this is all not needed. And all of these values will be const. And data will be props. This will be props dot wildfire data. We need to define the props here. Router, we already have Wildfire scatter map. So props and Wildfire heat map. Now Wildfire map home, we are going to bring that component. So import Wildfire heat map. Let's use the Wildfire heat map and see if we could. Wildfire data equals now we need to show the data here. It means the widget is rendered correctly. That's our widget and it's using this dark map style and it's going to use the longitude 103, zoom will be 3, make it zoom 2, props dot wildfire. Now we need to say d dot longitude and d dot latitude, and the weight for this heat map will be d dot confidence. And there you go. As you could see here, our heat map is visible. Now we need to make it more accurate according to our requirement. So intensity is 1, threshold is 0.03 and radius pixel is 30. So let's try to make it 5 actually, because that's where the pixel, now you see that 5 is okay. Let's make it 3 and that's where your maps are. So you can see the fire map is quite similar to what we have seen earlier, and that is similar to this NASA fire map. So here you can see the fire, and if we try to zoom, that's the Hawaii, and these are the fire, and that is our chart. Color range, I have an example color range, so I could use that color range here. So this is the color range because it's a confidence value, so color range will definitely going to work here. Let's use color range. Color range is working, and depending on the need it can. And as you could see here that this is the modest data where the confidence is value, but if we look into the VIIRS, the confidence value is nominal, or so it means that the value in the confidence we have to processes before we are going to able to use this VIIRS data. So I'm coming over there. So at least we have our map ready. If we would want to make this color more red and yellow oriented, start from yellow and then goes to red, then we need to change this color range to more yellow and red base. So for example, if we say this is 200, 50, 50, so more starts from red. As you could see, this is red, and so this is more red. And then if you would want to make it more yellow, so this will be more, that's 250, 100, 100. So at least we have our code working in a way that whenever we wanted to show these maps, these are visible here. Next, we are only sending one data set. So now we need to merge these two data set and make one single data set, and that's we need to process it. So let's work on merging these two data set now. Update full wildfire data, and here we can say where temp data equals to modis wildfire data, and we can say temp data equals to temp data dot concat, and we can merge the VIIRS data and return temp data. So now the both data sets are merged. The only problem is that the confidence value between these two data sets is not matched, because the modis has the confidence value between 1 to 100 and the VIIRS has the confidence value into nominal. So we need to process this data set, convert these nominal high and low value to low as 1, high as 100 and nominal as 50. So let's work on that now. So now we will create a function called update wildfire date, update wildfire confidence, and we will say var local data equals to this data. So we can say this dot this. So now we have full data, merged data is available for us, and you say if so we local data length. So if local data dot length is greater than 0, you can say local data dot map. Here will be item. Okay, and then now we need to get confidence value. So we will define where conf is equal to item dot confidence, and then we can say if type of conf is not equal to number, because if it is not number we need to fix it, or if it is number okay. So if type of conf, this value is not number, it means it could have three values. So it could be if conf is equal to nominal, else if, and then else. There are three values, so it could be nominal, it could be high and low, so it could be low, it could be high. And how we can find out? We take this data, search for confidence value, and you are going to see here that we are getting confidence value number, and then later we start getting this nominal, we are also getting low, and we are also getting this value high. So it means these are the combinations we have. So if nominal is 50, if it is low, we just call it 1. If it is high, we just call it 100. By any reason, if something is not right here, we will set for 50. So now we got conf. If conf is not number, we have set one of these value. So that became our conf value. So we have item. So item is there, and then we can define where final data, which is empty array, and after that we fill that array, push item. Return final data. So this is our final data whenever it will fix problem with your number problems, and this we will be calling, this will be our final data, and that final data will be used to update these two data set up MODIS as well as the VIIRS. So they are combined. Now we need to set them up at very first. So we call it Wildfire full data equals to empty, and when this page will be loaded, we will call this method, this dot here, and that will set it up. So this dot set state and Wildfire full data equals to this. There you go. So Wildfire full data is our final object here. So this dot state dot Wildfire full data. Now this data is a lot more data, because let's reload it and make sure this is the data. Now if we would want to make sure that how many values we are rendering, we can actually show those count here just to make sure that we are rendering that many values. So here I will just make sure that I'm writing that value. So I will say this dot state dot Wildfire full data dot length. So the total record count will be visible here. Reload. Data. And as you could see here, we are getting that many records in this. So 56,989 records are being rendered here. So it means both of the data set we have merged from MODIS and VIIRS, and we are showing the combined data in our graph. So at least we have solved one of this problem. In this next step, we are going to create a drawer component. So let me show you what is the drawer component is that. So drawer component, it's something like that. You click here and a side panel opens up. We can write controls over here. So we are going to write the control so that we could filter on today versus 3 days or the 7 days data. Similar to we can filter the data based on MOBIS or the VIIRS data set. So we are going to add the drawer first, and then we are going to work on it next. So let's add the drawer component. So similar to here, if we want to add drawer, we need to add these components. So, and that's going to be in our home page. And here is your drawer example. So drawer need a button to be able to open it. So that's where here is our drawer component. So that's the button. So we need to add a button here. So in this area where the React Map.gl view buttons are, we will add one more button here. So button group, after button group, we can add one more button here. And that should be ... And we just call it on click. And that button is going to set up the open drawer. So this dot set state, and that will be open. That will be this dot state dot open drawer. So it will reverse the state, whatever open drawer state is, and open drawer is false at start. So that button is added. That button is here. If we want to change this color, we could change, but I think that we could do later. So that's where the drawer is. Now we need to add the drawer component. So that's the button here, and let's add drawer at the here. So DRAW drawer. So that's the drawer component. So drawer, there you go, is open. So open drawer is true. Open drawer placement is going to be right side on close. This dot close drawer. So we need to add a close drawer function here. This dot set state, and the same item, which is open drawer, must be false, because this time we are not changing the state, reverse state, we are just making the option is false. Inside drawer we can bring the component. So drawer open, place, then drawer overlay all the way to drawer content. Drawer, this will be our Wildfire data setup or filter, and we don't need input here, so that will be it, data here. So we could actually show the footer cancel. Cancel is going to call the same close drawer. This dot close drawer dot bind this, so that will be the close, and here will be data. So we can say horizontal stack. So first we need vertical stack, width full 100%, and then we can say horizontal stack 100%, and right now we just call it text hello. At this point, if click happens and our panel is visible, so click and panel. So that's where the controls are going to be added. So this is the place where we are going to add the controls. So very first horizontal stack, we can say border equals 1px, border color red.100, rounded LG, so that okay, and so round, so we have added, and here we could say these values. So total values will be here, whatever the current. So text total wildfire data points, this dot length, and that's where our total records are there. We can add the heading, have the 5 headings, so it will be much better visibility. So that's our data total and total data points. Now we can add another layer for the buttons. So I do have a whole kit built into, so let's use this one. So that will be a little faster for us. And update data, so just give me 1 second, then I will come back and I will explain. This will give error. So we have added these 3 buttons here: today's, 3 days and 7 days. So this way we could filter the data for today, 3 day and 7 day. And what happens is that whenever we are trying to select these options, we have to filter our data. So our data, we already know that our data is being combined, merged here. So depending on what our date system is, today means today's data, means last 24 hours, or 3 days, or 7 days. So last to today, or we can also call it 24 hours. So 24 hours is our last 24 hour worth of data. That will be here 3 days and 7 days. So this update data method, what it does, it actually takes the data and filter it at this point. So we are going to take this data and try to filter it based on our method, whether it's how many days we need to use it. So this is our update data. So we have to pull this. So this is a fire confidence. So fire confidence is needed. So this is our correct data right now. So update data, let local data equals. So we have all this data, correct data is there. Now we need to take this local data and we need to check the time span. So time span is what coming out from this updated data method. So here 1 day means 24 hours, 3 days means 3 days worth of data, 7 means 7 days worth of data. So time span is coming here. So we just need to process the time span. If it is a 7 days, then we already know that 7 days worth of data we have already collected. So if time span is less than 7, then we need to process it, otherwise return local data. So if else, so if less than 7, we need to return something else, otherwise return as it is data. Time span. That should be okay. Next, we will take this local data dot map okay. Now item is the value here, so we need to select the what is the today date. So where today date equals to new date. So we got our new date. Let's take a look into the data set. There is a one problem. The date which we have here is actually stored as a string value in both data sets. It means we have to convert this value from string to date time, and that's a problem. We have to fix it in our reading. So in this scenario, we need to if new date, and we need to take this item dot field name acquire date. So if new date, so we are converting this date to date string to date object is greater than whatever our today's date is. A today's date dot set date, then today's date dot get date, so it will tell us whatever the date is minus the time span. There you go. So now this check will say if the date which is available, if the date which is available right now is greater than the given date minus 1 day or 3 days time span. In that case, we need to select where final data equals to empty array, and we need to push the item, and this final data will be the return from here. So if time span, I hope everything is correct here. This, I think, yeah, it's perfect now. So final data will have update data. Update data will change this data. It means that once this thing is coming, so update data. So actually, update data will have the time span, and this dot set is date, and whatever our final data set is, which everybody use, Wildfire full data, and that will be update update data for selected time span. There you go. So update data will call this method, and that method will update. It will read merge data, which has all the confidence value fixed. Then based on time filter, one of the value will be selected, and depending on whatever the choices are, this will be set. Now let's see if everything works. Here we have 7 days, 3 days, yeah, value is changing. 7 days is all data, 3 days all, and 24 hours, because currently the date is already 29, so we already are 1 day older data. So for that reason, this whole time span has to be adjusted. That value will be solved if you have or more data. So because of data is already 24 hours old since I downloaded this data. So our time value is fixed. Next, now we need to filter our data set based on our MODIS as well as the VIIRS instrument on the 3 satellites. So let's take this. I have that code also available. So this is another horizontal stack, and it is going to have the MODIS and as well as the VIIRS. So so this is a checkbox. So it's a stack and checkbox is not defined. So let's add the stack and checkbox. So we have a stack and checkbox are added. Okay. So stack and checkboxes are added. Let's see. So we have setup instrument. We need to set up the setup instrument button. What is it? Okay, I will come back and explain. So we have these two. So we have instrument MODIS and instrument VIIRS. So here we have checkbox. If you select these two, whether you want MODIS data, you want VIIRS data, you want both of the data, and then you need to select it. So you select any of these values, and then we need to say, okay, so these are the two instrument MODIS. So by default is true. Same thing, we have instrument VIIRS. Let's make them true. Okay, so these two values are true by default. So when system start, and then if you change them, these values states are updated. It means when this data will be selected, it automatically checks whether the what selection is happening, and then when OK happens, it looks into the state and try to update your data set. So when this wildfire data is being loaded, we have to select what kind of data we are selecting here. So, because right now we do not have any consideration of whether you are selecting MODIS or you are selecting VIIRS. So here I could add that check. The check will be something like this. If this dot state dot instrument MODIS is true and this dot state dot instrument VIIRS both are true, we need this data. Correct? Because this is your final data set. So let's have, so where local data equals to empty. So okay, so later. Okay, else if out of these two, one is true. If this is true and this is false, in that case your local data will be if MODIS is true and instrument is false, then MODIS will be the only data. Else if this is true but MODIS is false, then local data will be the VIIRS data and local data will return from here. So update wildfire data already knows depending on what it's set. Let's try to check it. Right now both are set. If one is set, now when this update happens, we need to update this data set because that is not being updated. So setup instrument should call this. So right now both are true. How much? Okay, all values. If only MODIS, 7,000 record, that is correct. If only VIIRS, 46,000 record. It means the filtration is done. So we have MODIS and VIIRS data is set up here. In next step, we are going to add the range slider. So let's take a look at the range slider here. So this is the range slider, and range slider, something we could select the confidence value, whatever we want to set it up. So let's add the range slider here, our range slider, and we have to add range slider component types. So these are the range slider. Okay, and that's for updating confidence. So here is our range slider value. So now, so range slider has a minimum 1, maximum 100, step is 5, min and max, pin color, default value is total 1 to 100 by default. Update confidence. We can update this wildfire confidence value. So let's update the update confidence. Here is the update confidence, which will call update wildfire confidence, and that's the conf. Final. So after we have added this wildfire confidence value, let's reload, check. So wildfire slider is working, and this slider holds the value in this well, and this well is being sent with this update confidence, and when it arrive here at update confidence, it has the array of min and max. So this min and max value will be sent to wherever we need to update. So update wildfire confidence. If there is no value decided, then value is 0 to 100. If it is not decided, here is 0 to 100, and update here, it will be the min confidence and max confidence. So we have this, and we can just say if conf is less than equal to min conf and conf is greater than or equal to min and smaller than or equal to max conf. Only then we need to fill this array, otherwise we should not select that particular data point. This value is not changing. It means these slider values are not active. So this is the update confidence. Let me validate one more time. Value is being sent up to here. So this is working. And the confidence calls the final. Oh, this is wildfire data. Okay, now let's check. 56,000 records are reducing, but you do not see big changes here. But if you try to go from that way, you will be able to see more changes. It means if we use this way, and we could see the changes in our slider. So you can get an idea that our slider is also working. Now one more thing I would try to add also, last one will be to add this map type, because background, we have different variety of backgrounds available in the map GL, React map GL, and those values are defined based on map type. Let me show you scattered map, or we also have widget scatter map and heat map. So these are the Cartosian. So these are the different styles available. So let me show you base map, map, GL and base map, and here are the different maps available. So we will try to take this positron, VIIRS and dark. So currently we are using the dark matter with the label. So let's add this positron, dark matter and VIIRS, these three map, and create an array. So I do have a list of maps available. So here is our map style. So we could use this map style here as the base map style, and we could select, we have streets map. So the VIIRS is the streets, dark is the dark matter, gray is the positron. So this is what we have. We do not need this map style, and map style will always going to be selected by the, so sorry, I made a mistake. So this map style will be sent from the master or the main, this map style, and we can set up a map style as a state variable. So map style going to be the map style dot dark is the default one. So this is the default, and map style is going to be sent by the props map style equals to this dot state dot map style, and whenever we are getting heat map, we can say map style is equal to map style. So props dot map style. Same thing, the scatter map, where is the map style? Map style is going to be the props dot map style. Let's see the map here. Reload. Right now is a wildfire map home, wildfire heat map. Map style is using the props dot map style. Very good. What if we change this to default is dark? What if we change this to streets? Yep, it's changing. So the map style is changing depending on whatever we try to select. So this is more, it gives us better clarity what we are watching. So dark is kind of very hard to watch. So now we will set those map style through our control. So I have already created these some of the code templates, so I don't really need to type too much. Vertical stack. So here will be our map style. So we need simple grid. Okay, let's see what we have done. We have added these layout design. So we have dark, gray, and streets. So these three map styles are added through the state variables. So now the map can be used that way too. I will be creating the new map which is based on hex bins. So I will create a new widget, wildfire hex map.jsx. I already have the existing code related with wildfire hex map, so I will be using it. It is a very simple code. What we are doing, we are using the Hexagon layer. We are setting up the Hexagon layer. The wildfire data is coming as a props. Same with wildfire map style. So the both of them are props.map style is coming. So these two data is coming out from the parent component, and rest we are setting the heat map type layer, which is a Hexagon layer, and it uses the longitude and latitude and the elevation range. I will walk you through how it works. Let me load this wildfire data component first. So map home, integrate the import wildfire hex map. Okay, it's loadable. Now we take this and we try to add that component here and see if it works. There you go. Okay, so the wildfire hex maps are being built, and let's try to change the dark or gray. I have this dark, and this is where, so let me explain you. What you are seeing here, this is like a just 7-day worth of data, and if some fires are happening quite long, they have aggregated those value, and that's what you are seeing here in this long pole. If that value is not duplicated, then you see just a single hexagon point is available for us. So this is one more way to look into where the fire is. So that is our hex map. So now we can create an option to select which map we want to see. So in order to decide which map we want to see, we could set up these buttons in a way that they will be helpful for us to select which one we want to see. So here we are watching the heat map, or we can watch the hex map. So we have two options available, heat map and hex map. Here we call it heat map and hex map. So if choice is don't need this, you can say this dot state dot map choice is heat map, show the heat map, otherwise null. Similar to that, if it is this value is hex map, then show the hex map, otherwise show the null. So we have both maps are visible, and by default we need to select the heat map or hex map. So we can say the default choice is heat map, and that's is good for us. So we have heat map, we have hex map, heat map, hex map, heat map. Looks like they both are referring to same object right now. Hex map, heat map. Default is heat map or hex map, and you can choose which data you want. All that filtration, everything is still working. So that's heat map, hex map. We also have the scatter map. If we would want to integrate that, we can also integrate that, and we can say first one was scatter. It's not applicable here. Wildfire. Is scatter map, and we need to add one more scatter map. So we have three options available: scatter map, heat map, and now you could see that the heat map has a little bit straight, hex map is little tilted. So how it is there, and the scatter map is also not tilted. So let's try to fix this thing. So in order to make that happen, the map type we can look into the hex map already has, and that is because the pitch and bearing. So pitch is 50 and bearing is 0. So that's why it's pitched like that way. But our heat map pitch is not set. So let's try to pitch it. let's do 10. You will see that our heat map is going to be start pitching a little bit. Now if I try to add the 20, you will see this start going to pitch a little bit at the top. If I try to make 80, you will see what's going to happen. It pitched a lot. Now, as you could see, the value is that way. If we try to go 60, but you see that the gap is coming at the very top, because when we are trying to, you could see that whole pitching is being thrown away but that's one way you could understand how you could set this thing. So I use the 50 pitch, which was good, and then same thing I will go with the scatter map, where I will select the pitch 50. And if I go to scatter map, I could see how this wildfire values are invisible for me. So this is the scatter map. Here is the hex map, and this helps us to see the values nicely, and it is our heat map. Review of our code. We started the existing code which we have taken from previous tutorial, where the map related components were already included. So mapbox.gl and the deck.gl, everything was already included, and those package definitions we have added here. So these components we added that made us help to get the map related component working, and that's what we have seen in these components. So if we go to same example, map home, we could build these different maps. So the code was already there and it was working. Next we created the wildfire map route, and within the wildfire map route we have created these 3 different map. One is heat map, where we could see the wildfire situation in the United States, and then we added the hex map, where we could see these vertical hex, or the stack hex is coming into, which shows the number of fire happening, so the number of records, and in the same location. So it means that fire being recorded at the same location again and again and again for last 7 days. It means the higher the spike, it means the fire is burning for almost 7 days. So that's where the spike value is. Finally, a scatter map we just look into. So this is just a plain map which just shows the density of these balls wherever we have find the fire. Then we added this whole wildfire data control, so we could select if we are interested into 3 days or 7 days worth of data, we are interested in only the VIIRS data, or we are only interested in the modest data. So depending on what our requirements are, we could select any of this. Then we have also added the fire confidence slider, so we could filter out some of these lower or higher confidence value. And finally we have added the map, so we could get little more clarity in visualization what we want to see. So that's all we really had in our mind in this tutorial. So this tutorial is concluded. I'm just going to upload all of this data from here to GitHub now. Let me just make sure everything is here. So wildfire, okay, source JSON, okay, so git add dot git commit marks. So final wildfire project is updated at push status. All the code is being pushed. Let's take a look into the GitHub. So Chakra UI tutorial. We have Wildfire Chakra UI demo. Here is the final demo. Source. Look into the components. Here is our routes. Wildfire route is added there. Then we can look into the containers. Wildfire is there. Very nice. And finally, we can validate the data. So we have also added the data here. So if somebody would want to use this tutorial, they can also access it. So here is Wildfire. So Modis Wildfire data and the VIIRS Wildfire data, they both are added here too. So full complete project is available for anyone to pull this project and make it work. I will also add the README file for this project, which I will update later. So USA Wildfire visualization, and that should be enough right now. Okay, so this project should be good to go. Okay, so we have updated the code, so that code is also available for anybody to try. So this particular tutorial is completed from my side. There is a lot to learn, and I'm sorry there was so much data to comprehend and as well as digest. Hopefully, please use this video, pause it, look into the source code, because the full source code is also available for you to follow. So that will also help you to digest the information by pausing the video again and again, and then that's where you will be able to learn completely. So I am glad that you are still here after a 2-hour long tutorial. And this tutorial was very interesting from so many points of view. First, you learn how you could get wildfire data. Second, you could build a full web app showing wildfire data in a variety of ways using map.gl, deck.gl, and various other React components. While we were building web UI for wildfire data, we have also used various Chakra UI components. So that was another layer of exercise we have done. Overall, it was an interesting project to build the United States wildfire data using Chakra UI and various other components. I really enjoyed creating this tutorial for you, and I hope that you have also enjoyed the content in this tutorial. I'm sorry the content is quite long, but pausing the content and reviewing it a couple of times, you will be able to understand it. I do appreciate your time, and I thank for you to watching this YouTube tutorial. I appreciate once again. Thank you so much for your time. If you like it, please share it and subscribe it. And I'm going to look for you in my another tutorial. Until then, thank you so much. Thanks for your time. Please like it, share it, and subscribe it.